Remember when 3D printers seemed to be the topic of every headline? While the hype has mostly faded away, and you probably won't have one in your kitchen or living room anytime soon, 3D printing technologies have been rapidly maturing behind the scenes. Many types of businesses you might not even think of are already using 3D printers, and more will continue to do so as the range of applications continue to expand. In this video, we'll show you how 3D printing works, and the most common technologies, benefits, and applications. 3D printing, also aptly called additive manufacturing, creates three-dimensional parts by building up material layer by layer, based on digital models created using computer-aided design or CAD. While 3D printing technologies have been around since the 80s, recent advances in machinery, materials, and software have made them accessible to a wider range of businesses beyond a few high-tech industries. Today, desktop and benchtop 3D printers accelerate innovation and growth across various industries, including engineering, manufacturing, dentistry, healthcare, education, entertainment, jewelry, audiology, and more. But how exactly does 3D printing work? First, digital 3D models are either designed using CAD software or developed from a 3D scan. Then, the design is imported into a print preparation software to specify print settings and slice the digital model into layers that represent horizontal cross-sections of the part. These instructions are then sent to the printer. There are many ways to transform digital models into physical parts. Some 3D printers use a laser to cure liquid resin into hardened plastic, while others fuse small particles of powder at high temperatures or melt plastic filament to build parts. Depending on the technology and the material, the printed parts generally require some sort of post-processing, such as washing, depowdering, removing support structures, post-curing, or sanding. 3D printed parts can then be used directly or post-processed further for specific applications by smoothing, painting, coating, and more. Forget about the layers. Today, you often wouldn't be able to tell that parts have been 3D printed. While there are 3D printers that can print metal, wood, and concrete, the most common type of 3D printers print plastics. The three most established plastic 3D printing technologies are fused deposition modeling, or FDM, stereolithography, or SLA, and selective laser sintering, or SLS. FDM is the most widely used form of 3D printing at the consumer level, fueled by the emergence of affordable machines for hobbyists. FDM 3D printers build parts by melting an extruded thermoplastic filament, which a printer nozzle deposits layer by layer. FDM printers work with a range of standard thermoplastics such as ABS, PLA, and various blends. The technique is well suited for basic proof-of-concept models as well as quick and low-cost prototyping of simple parts. SLA was the world's first 3D printing technology, and it remains one of the most popular technologies for professionals. SLA resin 3D printers work by using a laser to cure liquid resin into hardened plastic in a process called photopolymerization. Because SLA parts have the highest resolution and accuracy, the clearest details, and the smoothest surface finish of all plastic 3D printing technologies, resin 3D printing is a great option for producing highly detailed prototypes and parts requiring tight tolerances and smooth surfaces, such as molds, patterns, and functional parts. SLA 3D printing also offers the widest range of materials for various applications. It's used in a range of industries from engineering and product design to manufacturing, dentistry, medicine, jewelry, model making, and education. SLS is the most common additive manufacturing technology for industrial applications. SLS 3D printers use a high-powered laser to fuse small particles of polymer powder. The unfused powder supports the part during printing, eliminating the need for support structures. This makes SLS ideal for complex geometries including interior features, undercuts, thin walls, and negative features. Parts produced with SLS printing have excellent mechanical characteristics, with strength resembling that of injection molded parts. The most common material for selective laser sintering is nylon, a popular engineering thermoplastic that is lightweight, strong and flexible, as well as stable against impact, chemicals, heat, UV light, water, and dirt. The combination of low cost per part, high productivity, and established materials make SLS a popular choice among engineers for functional prototyping and a cost-effective alternative to injection molding for limited run or bridge manufacturing. Wondering what makes 3D printing so beneficial to so many different industries? First, it's fast. With traditional manufacturing processes, it can take weeks or months to produce a part as you first need to create tooling, while 3D printing turns CAD models into physical parts within a few hours. This allows designers and engineers to develop ideas faster and companies to bring products more quickly to the market. Second, it cuts cost. With 3D printing, there's no need for the costly tooling and setup associated with traditional manufacturing tools. While traditional processes like injection molding are still cheaper and might always remain cheaper for mass production, 3D printing can increasingly complement or replace these methods for a growing range of low to mid-volume production applications. Third, it offers unprecedented design freedom. 3D printers can create complex shapes and parts, such as overhangs, microchannels, and organic shapes that would be costly or even impossible to produce with traditional manufacturing methods. This provides the opportunity to consolidate assemblies into fewer individual parts to reduce weight, alleviate weak joints, and cut down on assembly time, as well as unleash completely new possibilities for design and engineering. Which brings us to the last point, customization. From shoes to clothes and bicycles, we're surrounded by products made in limited, uniform sizes as businesses standardize products to make them economical to manufacture. With 3D printing, only the digital design needs to be changed to tailor each product to the customer without additional tooling cost. This transformation first started to gain traction in industries where custom fit is essential, such as medicine and dentistry. But as 3D printing becomes more affordable, it's increasingly being used to mass customize consumer products. New applications of 3D printing emerge every day. In general, they can be grouped into 5 categories. The first one is rapid prototyping, where 3D printing is so common that it has practically become a synonym for it. Rapid prototyping with in-house 3D printers empowers engineers and product designers to create realistic and functional prototypes within a day and carry out multiple iterations of design, size, shape, or assembly based on results of real-life testing and analysis, helping them guide products through a series of validation stages toward mass production. The second is rapid tooling, where fast, low-cost 3D printed tooling can replace expensive, traditional tooling for manufacturing processes like injection molding, thermoforming, or casting. 3D printed rapid tooling enables companies to validate the design and material choice prior to transitioning to mass production, and can also provide an affordable means to produce custom or limited series of end-use parts. The third group of applications is manufacturing aids, which are vital tools for addressing common problems that arise during manufacturing. This includes custom jigs, fixtures, tools, and replacement parts. 3D printing can be used to improve the efficiency of the manufacturing process, reducing cost and improving production. The fourth is bottles and props. 3D printing is a great tool for creating complex and high-resolution models with fine details and a smooth surface finish, saving time and money. In-house 3D printing is used by businesses around the world to create professional models for various applications such as dental and medical models, movie props, educational tools, architecture models, and more. Lastly is the category that holds the biggest growth potential, 3D printed end-use parts. With 3D printing, you can directly create end-use parts without tooling, making it possible to create custom or low-volume parts and complex designs in a cost-efficient manner. 3D printing is unleashing new possibilities and business opportunities. What used to be too complex, prohibitively expensive, or impractical to produce with traditional methods is available at no extra cost, giving full control to designers and manufacturers, and opening the door to fully customizable products to become a reality. 3D printing is not a futuristic concept anymore. There are more 3D printers in use today than ever before, and chances are they're actively being used to shape your field. Want to take the wheel? Consider how 3D printing can improve, expand, or diversify your business now. Subscribe to our channel for more 3D printing videos, and check out the links in the description to learn more about Formlabs 3D printers and our range of over 40 3D printing materials.